Today we're going to be looking at the volume of spheres. This is our third learning target on three-dimensional shapes that have curves in them that we are looking for volume. So it says the volume of a sphere is the number of unit cubes or cubic units needed to fill the sphere. And you can find the formula for the volume of a sphere by comparing it with the volume of a cylinder, with the height and diameter equal to the diameter of the sphere. So you notice the height of my sphere is going to be the same as the height of my cylinder, and the diameter of my circle is going to be the same as the diameter, or the diameter of my sphere rather, is going to be the same as the diameter of the base of my cylinder. So the sphere fills 2/3 of the space of the cylinder. So when we did cones, it filled 1/3 of that space. When we have a sphere, it fills 2/3 of the space. So that means we would do 2/3 times what we would think of as the base area times the height. Now remember, when we find the base area, that is pi r squared times height. So the pi, the r, the squared is familiar to you. Now the height of our sphere, if you notice, the height of our sphere in this case is 2 times the radius. So we can take out the height and put in 2 times the radius. So that means I've got a 2, which goes up front, and I'm multiplying times the radius. And I'm going to kind of stretch this out here. If I have pi times r, that's what r squared is, times 2 times r. This is all multiplication, so I have 1, 2, 3 radiuses. So that's where I'm getting this radius cubed from. So I'm combining these because r times r times r is r cubed. So that's where I'm getting that. Then I still have the 2, which I'm going to put up front as the coefficient, and then I'm just tucking in the pi symbol there, and I can flip-flop those because this is all multiplication. Now, once I do this, this is the volume of the cylinder. In order to make it for the sphere, then I need to multiply it times 2/3. When I have 2/3 times 2, that is where I end up with this 4/3 here. And then I still have the pi r cubed, and that's where that all comes in. So that's where our formula to find the volume of a sphere comes from. So remember, this is the radius, that's the radius, so the height here is 2 times the radius. So that is where that comes from. So we're going to use this formula right here, and we are going to put it to work for us. So this one says, to the nearest cubic foot, how much space is contained inside the water walking ball? Use 3.14 for pi. So we have our formula up here. So to find our volume of a sphere, we're going to do 4/3 times pi times r cubed. So they have told me that I am going to use 3.14, and for my radius, I am using 3. 3 times 3 times 3 is 27. Which is then 4/3 times 84.78. So this number times 4 divided by 3. And I'm going to get that my volume is 113 and 4/100ths, and that is going to be in feet cubed. Go ahead and slide down to the next one. This is one of those ones where you're going to want to maybe pause, re-listen to stuff, just to make sure that you're understanding where everything is coming from. So take your time with this one. So here we have a quarter, and it's doing something that I struggle at. I'm not very good at this, but we're spinning this coin. And so when I spin it, you'll notice it looks like a sphere. So if I was spinning it and it's making that sphere, how much space is it occupying? And it wants us to round to the nearest hundredth. And it also wants us to use 3.14 for pi. So I'm going to use that same formula, 4/3 of pi times the radius cubed. Now, one little thing that they did here, they're giving us the diameter instead of the radius. So my radius that I'm going to use, we already have the 3.14, and my radius is 4,975 10,000ths. And I'm going to cube that. And I would get 0.1231. So that times 3.14, or times pi, 0.3866. And I'm going to multiply that times 4 and then divide it by 3. And I'm going to get that my volume is approximately, remember it wanted us to go to the hundredths place, 0.52 inches cubed. And this is one of these that, like I said, you're going to want to pause it and take a look back and make sure that you really understand it. Maybe try one by yourself and then restart it. Make sure that you know how to do this. Our next example here, and our very last example, it says an agate geode is spherical and has a volume of about 904 centimeters cubed. So look at this right here. They're giving us the volume. That tells me right away we're going to be looking for one of the missing pieces. It says geodes are often found in gem shops sliced in half like this one shown. What is the radius of the geode? So we're looking for what is the radius. So when I have my volume, and I'm using my formula to find the volume of that sphere, I am going to be able to substitute some things in. So my volume is 904. 4/3 stays the same, 3.14, but I don't know what my radius is. So I'm going to go ahead over here and do 3.14 times 4/3. And I'm going to get 4.19. So that is my coefficient. This is my coefficient, so I'm going to divide by my coefficient. And I get 215.75. And that's approximate because we're already rounding. There's already a bunch of decimal places, as you can see. Now on my calculator, I want to show you how to do this. I'm going to use this caret symbol down here. Now if I wanted to do like 8 to the 6th power, I could use it to do that. But I could also use it if I use the second shift button. When I do that, it wants to put my answer out there, but I want a 3. So all I have to do is retype in that 3, and this is going to give me a cube root. So then I'm going to put in that 215.75 on the inside. So this is taking the cube root instead of the square root of this number. And I get approximately 5.997. So it still looks like a square root, but it's got the little 3 out front. So I'm finding that my radius is approximately 5.99. Now this 7, when it starts to round things up, is going to make this 6. And so the radius of my geode is approximately 6 centimeters. The partner practice, once again, is on Schoology, and you want to show your work in your spiral notebook. Let me know if you have any questions.